Welcome and hello. This is a video exercise in HEC RAS. And in this exercise, I'm going to be demonstrating adding additional flow to a reach. All right, so we're going to get started from the very beginning here. What I have is my HEC RAS up here, and I'm going to go File, New Project. And then I'm going to first navigate to my project directory. So I'm going to click on this default project folder, which is basically a shortcut to a dedicated folder on my local machine, and then navigate to the particular folder. And then I'm going to give this project a name. We'll call it exercise 2. So that is the name of that is the title of the project, and then the project file name will be exercise2.prj. I'll click OK, and now we are rocking and rolling. By the way, to specify a default project directory like I just had, you could go up to Options and then Program Setup, and then over here, Default Project Folder. So what you do is you navigate to the project folder and then click OK. All right, let's get started here. I'm going to start with the geometric data editor. And then to start, I'll click on River Reach and then sketch out a river here. Just a single left click to start, and then a single left click wherever you want to add a vertex. But when you're done, just go ahead and do a double click and then go ahead and name that river and reach. I'll call this River A, Reach 1. Okay. What I'm going to do here is add a second river, and that's going to intersect this first river that I've already sketched out. So again, river reach is selected. You're going to want to sketch this in the upstream to downstream direction. So I'll start with a single left click, and then I'm going to do a double click about halfway up this river reach, just boom. And it's again asking me to name the river and reach that I just sketched out. So I'm going to call this River B, Reach 1, and then click OK. Now what it's asking me is, do I want to split River A Reach 1, which was the first river reach that I sketched? And the answer is yes. So now what I need to do is specify a river name and reach for what I believe is the downstream segment. So River A Reach 1 will be the upstream segment, and then this downstream segment I'm going to say is River A still, but this is going to be Reach 2. So I click OK, and now it's asking me for the name of the junction here, which is going to be the confluence of River A Reach 1 and River B Reach 1. So I'll just call this Junction River AB Reach 1. Okay, it looks like I ran out of characters. I'll call it River AB Reach 1. That's a terrible name for a junction. I don't care. It's my only junction. I'll get better at naming junctions. All right, so there we go. We have our river schematic set up here on the map. Let's start by adding some cross sections. So I'll click on cross section. Now what I need to do is specify, is it River A? Is it River B? And if it's River A, is it going to be Reach 1 or Reach 2? Reach 2 is my downstream reach. And I'm not 100% sure if that is the conventional way of numbering reaches. It may be lowest reach number at the downstream end, but I'll look that up. For now, this is what I'm going with. All right, so let's go ahead and start with a cross section at the very bottom of this river schematic. River A, Reach 2. I'll go Options, Add a new cross section. This will be for cross section 0. Then I'm going to go ahead and just start typing in some numbers here. From left to right of the cross section, I'll go station 0 and then 90. And so this is the cross section I sketched out right here. Now I'm going to add some data over for the downstream reach length, the Manning's end values, and then the overbank will be at station 300 and 700. I'm going to click on apply data, and now I can see that I messed that up somewhere. Okay, so I need this to be 65, and then this will be 1000, and then this will be 90. Okay, let me apply data and see what that looks like. Okay, good. I wanted the left and right overbanks to be symmetrical. It looks like I've got what I want now. All right, so what I'm going to do is copy this cross section up to a few different locations and only change the invert. Not or the invert, but the elevation of all the points here. So let's do that by going Options, copy the current cross section. Let's put it 10,000 feet upstream of the current cross section, and that'll be up at the junction here. That's River A, Reach 2. Click OK. And the only thing I'm going to do, well, I got to change this value. So there's a change of 10,000 feet downstream. And then I'm going to adjust the elevation. I'll say it's a 20-foot drop across that 10,000 foot run. That's again 0.2%. And then click apply. Now what I'm going to do is copy this cross section I just created to be the downstream cross section for River A reach 1 and River B reach 1. So it's going to basically be the same cross section down here at the junction location. So to do that, I'll go Options, Copy Current Cross Section. This is going to be River Station 0, but it's going to be for River A reach 1. Okay. And I think I need to put a 0 here. Okay, let's give that a shot. Apply data. And then I also want to make a copy of that for River B reach 1. So copy River B reach 1, River Station 0, click OK. Okay, I guess I don't have to click Apply data. So now what I want to do is create a cross section for the very top edge of these two reaches, which is just going to be another, say, 10,000 feet upstream of the junction, and then we'll give it another 20-foot rise. So hang with me, we're almost done. Options, copy the current cross section. This is going to be 10,000. Okay. I need to put 10,000 right here for the reach downstream. And then options, adjust elevation, 20-foot change there. All right. Apply data. Now I need to do the same thing. I'll just copy it over here. So go options, copy current cross section. This is now going to be River A, reach 1 at River Station 10,000. Okay. And looks like we're good there. Let's go ahead and double check that it is correct. So I'm going to close this dialog box for the cross-section data editor. And we see on the map that we do have some cross sections sketched in here, so that's good. I'm going to go ahead and double check that the cross-section data is what I expect it to be. So let's start from bottom to top. River A, but reach 2. River Station 0 is down here. It has an invert of 30 feet. And then the next river station at the junction should have an invert of 50 feet. So arrow up, 50 feet. That looks good. That should be the same cross section at the bottom of these two reaches. So we'll go River A, reach 1, and that's checking River Station 0 first, invert of 50 feet. That looks good. And let's see, River B, reach 1, River Station 0, invert of 50 feet. Correct. Finally, the top two cross sections should have an invert of 70 feet. So that would be River A, reach 1, and that's here. Okay, correct. River B, reach 1, 70 feet. Okay, I'm confident that looks good. Now I'm going to add some interpolated cross sections just to assume that it's a linear constant slope between the cross sections that we've already sketched in here. So I'm going to go Tools, Cross Section Interpolation, within a reach. This will be River B reach 1, so this one up here, that's fine. We'll just put it every 2,000 feet, interpolate, and close. So those are all sketched in, ready to go. I'm going to do the same thing for both reaches in River A. So I'll go Tools, Cross Section, within a reach, River A. Let's go, all reaches, cool. Yeah, let's see if this works. 2,000, interpolate, and close. Alrighty. We're now ready to add some flow data, some steady state flow data. So I'm going to go, first of all, save this geometry file before I forget. Save geometry data. Exercise 2 is what I'll call it, and OK. So now we have the title and then the file path for that geometry file up here and ready to go. Next up is edit steady flow data. Now we have the 3 different reaches shown here, and we have one profile. So I'm going to add a couple of profiles. So I'll put in, how about 3 total? And then let's see, reach 1. This is the downstream reach here. And then this is the upstream reaches, the first and third rows. So let's say 50,000 are going to meet at the junction, at the confluence, and that's going to result in 100,000 CFS. All right. I went ahead and filled out profile 2 and 3 just by doubling the flows from the previous profile. So this downstream reach here will have 100,000 CFS, 200,000 CFS, and 400,000 CFS of flow for the 3 different profiles respectively. Also, something I need to do is set boundary conditions. So I'll click on reach boundary conditions right here. We already have it set for the junction for what would be the upstream boundary condition for my downstream reach and the downstream boundary condition for my 2 upstream reaches. But I still need to set the boundary condition for the upstream end of the upstream reach and downstream end of the downstream reach. I'm going to keep things simple, and I'm going to use normal depth here as my boundary condition. And then here, so this is just the constant slope of the channel. All right, so I'm going to click OK. Then I'm going to go File, Save Flow Data, Exercise 2, and then close that. All right, so we have the geometry data, we have the flow data. This is a steady flow simulation. So let's click on the running man character. And then here for file, new plan, I'm going to save this plan, call it exercise 2, click OK, and then also exercise 2 here for the short ID, which is using the geometry file, the steady flow file. I think we're ready to run it. So let's click compute and see what happens. All right, that looks good. So let's take a look at some of the results. I'll click view cross sections. What I'm looking at here is the results, but it's one reach at a time. So we have the river B reach 1. That's this section up here. So if I go down to the junction, you can see we're actually on profile 1. This is the lowest flow. And as I go upstream, you can see the vertical the vertical elevation is changing. So to prevent that from happening, let's see. So 130 is the highest. And then the lowest would be down here, which is, I believe, an invert of 30. So if I'll set the persistent or the fixed vertical range on this plot here to be 20 up to 130. So to do that, you can go options, set persistent scale. That's what it's called. So I'll say 20 to 130 and then click OK. Okay, that's better. So as we go downstream, you can see how the channel just goes downstream, but the water surface begins to get higher, or I should say the water depth begins to get higher. So this is probably going to be the exact same results as River A Reach 1. That's the part of River A that's upstream of the junction. But let's just go ahead and check it out to be sure. River A Reach 1. Here's the top. Yeah, so this looks pretty much the same. I could look at the numbers side by side to confirm. But now let's check out River A Reach 2. This is the downstream most part. So let's go to the junction first. This is going to have twice the amount of flow because the additional flow from River B is adding to River A up here at the junction. And then River A Reach 2 will have twice that flow. So here we go. I'm just going downstream. Looks good. Now what I want to do is not use profile 1 or even 2. Let's see what the high flow is. So I'm going to go options, profiles, remove profile 1, add profile 3, which is going to be 4 times the amount of flow, and then click OK. All right, now we have much more flow. Let's start again at River B, Reach 1. So this is right here is at the junction. It looks like we're almost overflowing. And as we go upstream, looks like there's a little bit less depth, but it still has flow in this overbank area. Yep, all the way up at the top. That's probably going to be the same for River A Reach 1. I'll just go down from here. So there's 10,000, 8,000, 6,000, 4,000, 2,000, and then this right here is the junction. All right, lastly, let's check out River A, except Reach 2 now. And I want to start at the junction. Okay, and now let's continue to sketch down. Interesting. So that's a lot of flow. Up here in the view menu, we can look at the water surface profile. So let's add all 3 reaches and then all 3 profiles. We can look at that data as well. We can also analyze this data if we go to view profile summary table. I like this one. It shows the river, the reach, the river station, and then the different profiles that are loaded. If we only want to see one profile, for instance, we haven't looked at profile 2 yet. I believe that's 100,000 in each of the upstream branches of the junction, and then 200,000 downstream of the junction through River A Reach 2. I can change it. So profiles, I'm only seeing profile 1 or profile 2 now. There's that. All right, so here are all the rows in this table. Let me make this a little bit wider. So here is the cross-section data for River B Reach 1, and then here is the cross-section data for River A Reach 1, which is over here. And then finally, where the flow is now 200,000 CFS, that here is the cross-section data for River A Reach 2. As you can see, the flow has doubled. It's increased to 200,000 CFS. And also the velocity has increased big time, probably doubled. But the flow area is pretty much the same. It seems pretty consistent. One part of this plot that I would like to see, and it's not part of the standard table that we're looking at here, is the depth. So we do have the minimum channel elevation. This would be the invert of the channel. The next column over is the water surface elevation. So you could get the depth by just subtracting one from the other, but it's sometimes nice to actually see that value. So what I'm going to do is go to Options, Define Table, What I'm doing here is I'm starting with this standard table that I already had on the screen here, and then I can add or remove columns. What I'm going to do is just add the depth to maybe a column like after the water surface elevation. So I think what I do is I come to the next column over, like critical water surface, and then if you know the name of the column, you can just double click it from here. I'm not sure what it's called, but I'm going to just type in the search depth, and then I get all of the additional variables that have the word depth in it. So I have to find that one, and I think it's right here, maximum main channel depth. That's what I want. I'm going to double click that, or I'm sorry, just click it once. Oh wait, it added right there. Okay, is that where I want it? Yeah, that should look good. I'll click OK, and that added right there. So 34.86 is indeed 64.86 minus 30. That's one way to add an additional column to the table. If you want to save this table, which is kind of now it's a custom table, I could go up to options, save table, give it a name. I'm just going to call it a standard one with depth, and then click OK. Now I got this new table, standard one with depth. So at any time I can go to some other table. Well, there's no bridge, so that's why that came up blank. But there's a junction table right here. Oh, this is pretty interesting to look at as well. So we have water surface above the junction, and then below the junction, energy grade, and then the flow should be 100,000 and 200,000. Yep. All right. Anyway, let's go back to users table. And then here is that users table, which I started with the standard one table right here, but then I added that max main channel depth value right here. Well, that's one way how to add additional flow is to have two river reaches converge at a junction and then continue on downstream. But there's another way I wanted to demonstrate how to do this. And this doesn't include adding an extra reach. It might be a little bit simpler. So what you do is you go to your steady state data and you click on this add a flow change location. So you want to make sure you're in the right location. And what I'm going to do is add to river A, reach 2, and I'm going to add it to cross section 4000. This is one of the interpolated cross sections, and click add a flow change location. So now what I want to do is add more data. I'm going to keep profile 2 and profile 3 the same, but for profile 1, I'm going to change this and say it's 200,000. So we're basically adding 100,000 CFS at this river station 4000. And apply data, file, save flow data. I'm going to save this as the flow data in the same flow file. I could have saved it as a separate flow file and then saved a separate plan and reran that separate plan for comparison purposes. But since this is just an exercise, I'm going to override it. Save this new flow data with the additional flow over the existing flow file, and then we can close that. Let's go ahead and run it one more time and then look at the results and call it good. So I'm running the simulation once again. I'll click close because it's done. Now let's go to view and let's go to water surface profiles. And what I want to do is only look at profile 1. There it is. And then also I only want to look at the downstream river A reach 2. So I'll check these check boxes off. All right. So now what I'm seeing is with the additional flow coming into this river station 4000, we see how that affects the water surface elevation, mostly upstream, but there's a pretty good dip. The steepest part of the water surface elevation looks to be between 6,000 and 4,000 on river station for this reach 2. We can look at these elevations by just going to the view profile summary table. And already it's isolating just our river A reach 2 for profile 1. So those settings that we made earlier for the profiles and the reaches has been saved and preserved. So that's nice. And the water surface elevation, as I said, was dropping 81, 80, 79, then all the way down to 672, 68, 64. So this is a huge drop between these two river stations, even though the distance is only 2,000 feet each time. Let me make this flow total column a little bit wider, and sure enough, we have that extra flow showing up as expected, which contributes to a noticeable increase in the velocity as well. So we could talk forever about these results, look at the plots, look at the numbers, but I'm going to cut us off there and just say that there's multiple ways to add flow to your river system, whether it's a separate reach that converges at a junction, or if you just want to click this add a flow change button in the steady flow data editor.